Hello my dear students, this is Akash HD. Welcome to the AHD physics classes. Hope you all are doing very good. So students, in this video we are going to solve the question from the chapter Laws of Motion. Came in which year? NEET 2023. Okay, so let's go through it. The question is, a block of mass 2 kg is placed on inclined rough surface AC as shown in figure. You can see here. And coefficient of friction is how much is given here? Mu. If G equal to 10 meter per second square, the net force on the block will be how much here? Okay, and here this angle is given. So let's take for example this angle is theta. No? Generally angle I am taking here. So what will happen that here, if we talk about here, the weight mg will act vertically downward here. Okay. After that what will happen that here, I will just draw here one rough parallelogram, like this here, like this parallelogram I will draw here. So here what will happen that here this will have one component and this side also one component will be there. Now you know very well, if this angle theta, this angle will be also theta. Okay. So this side component will be, remember that here, mg cos theta, and this side component will be how much here? Mg sin theta. Very basic. So now what is there? This block is having the tendency to slip downward. So to avoid this, there will be the one friction in which direction? To oppose the motion, this friction will be this side. This friction can be static, kinetic, depending upon whether the block rest or motion. Okay. And here what will happen that here, this is called the normal reaction, that will be always perpendicular to the surface. Okay. So if we talk about here, the block which is causing the motion, force which causing motion. Force which causing motion. So tell me please here, because of which force the block is having the tendency to come downward here? This is the mg sin theta. Okay, so m is given to g is 10 and sin 30 degree value how much here? 1/2. So what is coming here? 10 Newton. That means the 10 Newton force is acting in downward direction, that is causing the motion. After that here, this is one we have done. Next one we'll see force which opposing the motion. Force with opposing motion. Which force opposing the motion? That is called friction. So force which opposing the motion, that friction is given by, remember that here, if here also kinetic friction is a constant friction, after that static friction is there. Remember that here, I will tell you one thing, this kinetic friction is always constant. Okay, that is used to be the mu k into n, where mu k is called a coefficient of kinetic friction. After that there used to be the one thing, this is the if we talk about the limiting friction, that is the maximum value of the static friction, this used to be mu s into n, and this static friction is used to be the self-adjusting. Okay, so remember that here, when the block at rest, this static friction can be greater or equal to 0, less than or equal to limiting friction. Now that's why what I am telling you, this static friction is the limiting friction, it changes, it adjusts its value. Okay, so what I am going to calculate here, I don't know block at rest or motion, so what I will do, I will calculate the maximum value of the static friction, that is called a limiting friction. Okay, so what I am calculating, the limiting friction I am calculating, remember that here. Okay, so what I am writing here, I am writing here mu into normal reaction, mu into normal reaction, that means mu into mg cos theta, because this normal reaction will be balanced by this mg cos theta. Okay, so see here, mu value how much is given in the question? 1/√3. Now you can see here 1/√3. M value is 2, g value is 10, and cos 30 value how much coming here? √3/2. Is it? So let's see here, √3 cancel, 2 and 2 also cancel, and here what is left? Only 10 is left. That means we can tell here it is coming how much here? 10 Newton. Now you think the force which causing the motion 10 Newton, and the maximum value of the static friction how much here? 10 Newton. Is it? So both the forces are equal. That means the block in a which situation? The block in a rest situation. Block in a which situation? Rest situation. Remember that here. Okay. And when the block in a rest situation, the net force on the block will be how much? From the Newton's first law of motion, when any object in a rest situation, the net force acting on the object will be always how much here? 0. Okay. And from one more point I can tell you, now here even there is the concept of angle of repose also. What I am telling you, the concept of angle of repose. From there also I can still tell you angle of repose. What angle of repose tells that? It tells that this alpha, tan alpha should be equal to mu. Okay, angle of repose tells that the tan alpha should be equal to mu. Okay, and here what is the value of the alpha? If I calculate the angle of repose, so tan inverse mu, tan inverse 1 by root 3, what is coming here? The 30 degree. That is called angle of repose here. What is called angle of repose? I am telling you some new concept here, this one here, angle of repose. So what will happen that here when alpha equal to 30 degree, that time what will be both the forces will be balanced here. Okay, so what I am telling you in this situation, when alpha is less than theta, now this is the theta, 30 degree. So when alpha is less than theta, the block will be rest situation. Okay, when alpha is equal to theta, the block is ready to move, but still in which situation? Rest situation. But what is happening when this alpha is greater than theta? I think so reverse is happening. I did reverse. What I did reverse here, because angle of repose I have calculated here. Okay, so what will happen right here? What I am telling you, this angle of repose how much here? Alpha. So when theta is less than alpha, rest situation. Theta equal to alpha, ready to move. And when this theta is greater than alpha, what will be there? The block will be in a motion here. Okay, so what is this? This is the theta here, and what is here? This is the alpha. So if in case this angle is less than 30 degree, block will be in a rest situation. Angle equal to 30 degree, block will be just ready to move. And when this angle theta is greater than 30 degree, then block will be in a motion, and here kinetic friction will be available. Okay, so kindly see very well here. Is it, students? So I hope so. This question is very clear to you. Keep studying, keep growing.